Welcome to the Data and AI Summit. Hi, everyone. I'm Nandini. I started as a backline engineer in Databricks, and now I work in enablement. Before we begin, here are some quick disclaimers. I know probably you didn't expect this on this particular presentation, but do you struggle to feed your kid or maybe your dog? I have a dog who's a fussy eater, and some days he wants kibble, other days he even prefers grass, and there are days when he doesn't even take the favorite food. It really does not have to be so difficult with unpredictable situations coming in. I spend a lot of time feeding the dog without having to get him to do, okay, I'm so sorry. I'm just getting a little nervous. Is it okay if I restart? Okay, thank you. Okay. Yeah, I know you probably didn't expect this, but feeding a dog could be tough. Do you struggle to feed your dog? Sometimes my dog prefers kibble, other days he prefers grass, and sometimes he just won't eat his favorites. It's not so great to have unpredictable situations, and I spend a lot of time trying to feed him than I should. Feeding data pipelines isn't so different. Data engineers often wrestle with unreliable sources, constantly changing formats, manual pipeline maintenance. Ingestion becomes a chore. It's slow, fragile, and resource-heavy. That's where DLT Serverless comes in. It's just like switching to a consistent, balanced dog food that works. DLT Serverless simplifies ingestion, handles scaling automatically, and lets you focus on insights and not the infrastructure. Let's get started with a simple idea. Engineers never have to think about cluster sizing, auto-scaling, retries, or orchestrational complexities. They just have to write the business code, and the platform handles the rest. In the next 20 minutes, we'll go over declarative pipelines, which makes engineers' life easy, lets you build reliable data pipelines, go over some of the cool features that enhance your ingestion with zero tuning. When you build your next recommendation system, predictive maintenance, or fraud detection system, or any of the solutions, the foundation of all of that is data. But getting data could be difficult. Every data project starts with ETL, extract, transform, and load. Let's see a data engineer's journey. The focus of the data engineer is this box. They want to transform and aggregate the data to get business insights. But first, they have to think about where the data lives. Is it in data lake or data warehouse? Then they have to make sure it is good enough for the BI reporting, data science, machine learning, and there are streaming use cases, generative AI, and orchestration on all of that. Then there comes in version controlling, deployment infrastructure, CI/CD, data control, quality checks, governance, data discovery, etc. And then there are moving parts of operational dependency management, backfill, partitioning, checkpointing, retries, etc. While the focus of the data engineer was really the transformation logic. We really don't have to have the engineer to go and tailor through entire infrastructural details, while they should have been focusing on giving the reliable data. The time which could have been spent in innovation is spent on troubleshooting. This is really unrewarding for the data engineers, and it slows down business. The current process is complex, it's difficult to maintain, and with rigid architecture, it makes making any changes to the business really difficult. As your data evolves, your business need evolves, there will be more and more ops changes. Now remember the idea that we started with, that you don't have to have any operational changes. We don't have to worry about the operations, but you could just build a reliable data pipeline. It should not be so difficult. Having to create a data pipeline can be simple, scalable, and optimized for both cost and performance. The solution is declarative pipelines, which is fully managed, assisted by AI, powered by serverless, unified system led by data governance, and out-of-the-box solution, which is intuitive to build, automated to operate, and intelligent and flexible to meet business requirements. Reliable data pipelines are built on top of data intelligence platform. Your data sits on data lake. With unified data governance and the knowledge of your specific domain, you can apply AI to unlock untapped potential. All of this could be done at one single place, the data intelligence platform. As the summit logo says, the theme says, the data intelligence is for all. Let me show you my encounter with data intelligence just a couple of days back. I was struggling with mobile connectivity because I traveled international. I tried some SIM resets, some recharges, activation, the holy restarts of the machine. So none of them really was working. I tried to reach out to the local providers, but my handset was something which was not supported, and hence I could not even take a local SIM. This was really, really frustrating. The telco in this case was Vodafone, and they were able to perform some real-time analytics on the data that was available on me. They saw that I was trying to make some recharges, I was trying to make attempts on reaching out to the help, and they were able to even figure out the bottleneck to be the network. They reached out to me over WhatsApp rather than a text or a call because I didn't have network, and I also didn't have email configured. They offered me a personalized support with intelligent engagement. They helped me reach to a solution, although the issue was not completely resolved, but I felt supported, I felt that I was heard, and I had some solution. So now, Vodafone gets a customer who's not going to go away. That's the intelligent data that we want. That's the intelligence that we want in our systems. To ingest data into data intelligence platform, we use LakeFlow. You'll hear a lot about LakeFlow in the summit. LakeFlow is the future of data engineering. It is industry's leading data processing engine. Using LakeFlow, you can bring various small and big data sources into your lakehouse with native ingestion connectors. Using declarative pipelines, you can clean and enrich your data. And the LakeFlow built-in jobs offers you fantastic observability, triggers, and orchestration. So it ensures that you have automation from ingestion to transforming and to downstream consumption just at one single place. Let's move on to DLT. DLT, also known as declarative pipelines, is not a standalone tool. It's heart of the solution that delivers you fast and reliable, trusted data. It's part of LakeFlow, a unified system of data engineering experience built on top of data intelligence platform. With LakeFlow, the data engineer no longer has to perform patchworks of disconnected tools. It's streamlined experience that delivers data in a simple, scalable, and reliable fashion. LakeFlow is tightly coupled with serverless, with zero knobs, and quick startups and scaling computes. We now understand where declarative pipeline sits in the entire Databricks, so let's just get started with creating one. Creating a pipeline is really easy. With declarative pipelines, you just need to say what should be done and not how it should be done. You can say, create a streaming table or a materialized view from a specified source, and that's it. You can write code in plain, simple SQL or Python, whichever you prefer. The DLT runtime figures out the best way to create or update this table, saving you hundreds of lines of code in production, and it's less error-prone. Talking about less error-prone, there are some awesome features that we have. An IDE-like editor for pipeline authoring with fast validations, inline error check, and quick results for users who prefer coding. With our new multi-file editor, we are taking developer experience to another level. This looks great, right? To try out the multi-file editor, which is currently in preview, make sure you switch on the ETL pipeline editor option while creating the pipeline or later on from the settings. Let me walk you through some of the scenarios In the pipeline authoring experience, although this is not a live demo, you will be able to get a complete idea of how everything is set up. On the left-hand side, you have Pipeline Assets Browser, where you can create, delete, rename, organize pipeline assets under a default pipeline folder structure. On the top, you have a multi-file code editor option, where you can work with multiple files across different tabs in the pipeline. There's a pipeline-specific toolbar with pipeline-specific actions like dry run, scheduling, etc. On the right-hand side, there's interactive DAG to get the overview of how the flow of the tables is. The data preview at the bottom and other table-related actions could be seen. You can inspect your data of the streaming table and the materialized view. Next, there's table-level execution insights, where you can review insights about all the tables in the pipeline or a single one. The insights will refer to the latest run of the pipeline. The error tray on the right side summarizes across all the files whatever error you get, and in order to see the error, you can go to a specific file by clicking onto the error. The code editor has features of step-by-step development, that's selective execution. If you make any typo or syntactical error, you can see them inline. It lists down the stack trace and the details right there. From the error tray or the event pipeline, you can get to the further details and use Databricks Assistant to help you diagnose the error. The Databricks Assistant is a context-aware AI-specific tool. It works by analyzing user input, including code, queries, and leveraging platforms' metadata, documentation, and relevant suggestions and solutions. You could fix the error inline as well, allowing the Databricks Assistant to take over from here. It generates the suggestions real time. You can review and either accept or reject the suggestion. It highlights the error and the differences with color coding. If you do not want to write the code at all, you could use Databricks Assistant and give it instructions in plain natural language. The Databricks Assistant could be seen by this icon, the star symbol icon. You just have to look around for that. Or you can go to a new cell and click on Generate, give instructions, and review the generated code. In the query history, you can get the past runs and click to get further details like UIs, Spark UI, logs, etc. It's just pretty much like the Spark execution in DB-SQL. To start exploring the DLT serverless and materialized view that you have just created, just with a few clicks and instructions, again, in natural query processing, you can use Genie, and Genie understands the context and gives you accurate answers. You can build a report on top of that, and you can start querying the table. That's a lot on the new UI, from ingestion to quick consumption. Another reason to move to declarative pipelines is the unified batch and streaming solution in one single pipeline. Batch processing is cost efficient, but can introduce delays. Streaming introduces latency, but can be complex and expensive to operate at scale. And once a pipeline is built one way, switching to another one is a complete rework. DLT removes these trade-offs by unifying batch and streaming into one single framework. That means your team can adapt to pipelines and business needs without having to being logged into one approach. To switch, you can just change the trigger mode from in the pipeline mode from triggered to continuous and move from batched to streaming. When you're using serverless, there's low latency and low cost. You can look at the numbers. There's 5x reduction in latency and approximately 50x reduction in the cost when compared for materialized view, refreshed, done for serverless against classic cluster. Serverless is fully managed and versionless. Versionless is one of my personal favorites. Many a times you might have raised tickets saying there's nothing that has changed from your end, but the pipeline is still failing. So versionless, how it works is there will be upgrades via health-mediated releases, that is HMR. So if there is an upgrade and there's a failure that's detected on your pipeline, there will be a quick underlying rollback, and that is done without you having to reach out support. Your pipelines will continue to run as it was. Maybe you will definitely see in one of the previous runs to be failed, but the future ones would have succeeded. So the upgrades do not impact your scheduled runs. With Delta integration, you see great performance because you can use features like liquid clustering, deletion vector, predictive optimization, etc. For serverless, you also get incremental materialized view with Enzyme. That is, you can refresh a materialized view without having to do the complete recomputation, but just the new changes. With pipeline execution, where you can run multiple micro batches concurrently rather than waiting for all the tasks to finish, it gives further optimizations. There's also dynamic tuning for batches based on the amount of compute available. Photon offers faster read and write performance with vectorized I/O and gives you approximately 10x increase with Delta metadata queries. We've already gone through a lot of features, but there's a quick comparison where serverless can be used when you're having CDC data, SCD data, and it offers you data quality expectation, observability features. Photon optimizations are by default enabled in serverless, and you don't have to specify instance types. There's automatic instance scaling that prevents the out-of-memory failures. You get Enzyme with incremental refresh for materialized view, streaming refresh, only on serverless. There's instance scaling with fast startup and single inclusive build. When creating a pipeline, you can select serverless just by one single click, and it handles all the problems of under-allocating at peak hours or initial load seamlessly, and excessive resourcing when off-peak hours, avoiding you to pay for idle resources. It's either you letting Databricks handle the compute for you, or you can do the tuning yourselves. The only difference between serverless and non-serverless architecture is where the data plane sits. In non-serverless, it sits in the customer's workspace, and in serverless, it is in the Databricks workspace. Creating declarative pipelines is simple, performant, and it has low cost. With full UC compatibility, there's production-grade pipelines. DLT serverless is indeed a game changer with zero infra setup, enhanced auto-scaling, ultra-low latency, and native integration to UC and DLT. With serverless, there's no ops and just simple, reliable pipelines. There's a lot more features being announced in Data and AI Summit, so stay tuned for hearing about more of them in the keynotes. And before you go, here are quick recommendations for learning about declarative pipelines in the sessions, in some of the other sessions. Thank you. Thank you all. Please do fill a survey over here, and have a good day. Thank you.